In this video, we're going to use properties of logarithms. And here are the objectives. Work with properties of logarithms. Write a logarithmic expression as a sum or difference of log. Write a logarithmic expression as a single logarithm or log. Evaluate logarithms whose base is neither 10 nor e. So let's look at the properties. I've done some problems using properties before, and I've shown you the actual properties. So let me just go ahead and show you the properties here. The list that follows: A, B, M, N, and R are real numbers. A has to be positive, cannot be 1. B has to be positive, not equal to 1. M has to be positive. N has to be positive. So those are your main properties right there. And the ones we'll be focusing on, again, if you have the log of a product, you can write it as a sum of a log. And vice versa. Here you can go the other way. If you have the log of a fraction, it's the log of the numerator minus the log of the denominator. And then you have this one when you have a log of some number to a power. You can take that power and make it an exponent, or a coefficient, I should say. So the exponent becomes a coefficient. Okay, so you have your definition of log. And of course, based on this definition, the logarithm is an exponent. Log of x to base a is equal to y means x is equal to a to the y. So y is an exponent. Then of course you have your change of base formula. You have a calculator, scientific or graphing. You can take the log to base 10 or base e, natural log. But if the base is some other number like 2, 3, 4, whatever, then you use the change of base. So you can see the form. You can pick another base, and that becomes the log of the numerator. On the right side becomes the log to that base of m over the log of that same base you pick of that base we start off with, in this case a. And nobody in this right side, you want the b there to be either 10 or natural log logarithm, which would be e, because that's what your calculator has. So let's look at these problems then. So say it's given natural log of 2 is equal to a, natural log of 3 is equal to b, and the natural log of 5 is equal to c. Use properties of logarithms to write the following here in terms of a, b, and c. So let's start off with the first one. And remember, this ln here with no base indicated means base e, or natural log. If it's log with no base, that's base 10. So here we'll do this using properties of logs. The log of a fraction is equal to the log of the numerator minus the log of the denominator. So we get this. And they want to use these substitutions in order to answer the problem, work the problem the way they're asking it. We need to use these substitutions. So notice here we have a natural log of 5. That can be replaced by c. But let's go further here and say 6 is the product of 3 and 2. So now when you have the log of a product, that becomes the sum of those logs. So it would be the log of 3 plus the log of 2. Log of a product is a sum of the logs of those same numbers minus the log of 5. Now once you have those values, now you can just substitute. So we can say, okay, this is equal to natural log of 3 can be replaced by b. Natural log of 2 can be replaced by a. Minus, and the natural log of 5 can be replaced by c. So depending on how you wrote this, it could be b plus a minus c, or it could be the other way around, a plus b minus c. That's the solution to that one. Let's clear this now. Let's look at the next one here. This is equal to, so this is the natural log of cube root of 25. So the first thing we're going to do here is think of this cube root of 25 as 25 to the 1/3 power. And there's a property that tells me then if you have the log of some number or some expression to a power, you can take that power and make it into a coefficient. So that's what I did here. 1/3 here. This becomes a 25. Still have the natural log of 25. Remember, looking for these types of substitutions. So let's do this. This will be equal to 1/3. And we write this as 25 can be written as 5 squared. So once you have the log of a number to a power, you can take that power and then make it a coefficient. So this 2 comes out and multiplies the 1/3. So it's 2 times 1/3 is 2/3. And that becomes natural log of 5. Now let's do the substitution. This would just be 2/3. And the natural log of 5 can be replaced by c. So this becomes 2/3 c. Clear this then. And then we look at the next one. Natural log of 24. This can be written as 6 times 4. Now when you have the log, doesn't matter what base it is, when you have the log of a product, you can have, put this in parentheses like that. That's 4 times 6 is 24. This would be the same thing as the sum of those number, the sum of the logs. So this would be log of 6 plus log of 4. And so similarly to what I did in the first one here, the 6 can be written as the log of 2 times 3 or 3 times 2, either way. I don't have a 4 over here, so let's break this down into, so this will be plus, and this 4 is the same thing as 2 squared. So 2 becomes an exponent, so this will be a 2 here. And it's 2 times the natural log of 2. And now we have to break this up. So we have to come up here with log of 2, log of 3, log of 5 to get the substitution we want. So if I have a natural log of a product, I can write that as a sum of those logs. So it's the log of 3 plus the log of 2. This one I'll leave as 2 times the natural log of 2. And now I have a substitution I can use. Natural log of 3, that would be b. And of course here I can actually combine these. So it's 1 log of 2 and 2 log of 2. This would be 3 log of 2. Now I'll continue with this and say this is still going to be b here. Plus 3 log of 2, and the log of 2 is a. So this would be 3a. Cancel this. Now this one says write each logarithmic expression as a sum or difference of logs. In other words, it wants me to break this up. I have the natural log of the numerator, of a fraction rather, or a fraction expression. So anytime I have the natural log or any log of a fraction, it's be the log of the numerator minus the log of the denominator. So let's start off with that. I have a single log here. Okay, so this would be natural log of the numerator. So this will be 2x square root x squared plus 1. So again, the log of a fraction is the log of the numerator minus the log of the denominator. That's one of your properties that I just showed at the beginning of the video. So this will be natural log of x plus 3. And then this one can still be broken down. You can look at this as the log of this product here, the log of 2x times the square root. So that would be the sum of those logs. So this would be the same thing as the natural log of 2x plus the natural log of the square root of x squared plus 1. And that's minus the natural log of x plus 3. Now I can't do much with that one. That's about as far as I can go. Now this one I could actually break it up further and say this is the log of 2 plus the log of x. Or I could leave it this way depending on how specific or how detailed your instructor wants, but let me just go further on this one and say this is the natural log of 2. It's a log of a product. I could go like this. And this is the square root of x squared plus 1, so I could actually write that as x squared plus 1 to the 1/2 power. And then I could use the other property that says, okay, if I have an expression to a power, I can make that power into a coefficient, so I can bring the 1/2 here in front. And then this becomes just the natural log of x squared plus 1. And I bring the last term minus the natural log of x plus 3. And this is your expression. This expression right here is your answer. Now this problem works both ways. They might give you a problem like this, or they might give you this problem here and tell you to write it as a single log. In other words, I want you to get this expression. So you just reverse your steps. You just reverse the steps and get your solution. Now this one, similar problem, it's the log of a fraction. This one is base 2, log to base 2. So I look at that as the numerator and the denominator. So you have the log of a fraction, it's always the log of the numerator. So this would be log of x squared minus 4 minus the log to base 2 of the denominator, which should be x plus 5. And then this one, the log of x plus 5 to base 2, that's about all I can do with this one. But this one actually factors into x minus 2 and x plus 2. Again, I'm using the property, in this case, that states when you have the log of a product, it gives you the sum of the logs of those factors. So in this case, I can write this as, step out and just write this as the log to base 2 of x minus 2 plus the log this is x plus 2. Okay, so the log of a product is the sum of the logs of those factors. And then this, of course, is just minus. Can't do anything with this one. Minus the log of x plus 5. So the two types of problems that you can have related to this type of situation. Again, they'll give you a single log, and they'll say it like this: write each logarithmic expression as a sum or difference of logs. So you break it down into this, what I have right here, or this one I did right here. And then the other problem, they'll give you this result right here, and they'll say write it as a single log, so they'll want this result. So you just reverse your steps. Reverse your steps. Okay, so that's what they're doing in this one here. Write each expression, each log expression as a single log. So here I have a difference of logs. So here's what I'm going to do. First I have to make this into an exponent. So this becomes an exponent. So let me just do it this way, just to shorten the steps, because I pretty much showed you how to do it, but here's the way it works. First you go backwards here, so make this into a exponent, you make it over here, and then it has a minus here, so you just reverse it. You have the difference of logs, that you can write that as a log of a fraction, so this becomes then the log of x squared minus 25 over x plus 5. To the fourth. Okay, this goes over here, and then you have a difference of logs, so you can write that as the log of a fraction. And then of course you can simplify this. You notice that the numerator is a difference of squares, so that factors into x minus 5 and x plus 5. Difference of squares. And the denominator has x plus 5 to the fourth. So you have a factor of x plus 5 here. This divides out with one of these here. And this will make this a 3. So the simplified answer is the natural log of x minus 5 over x plus 5 to the third. Okay, let's clear this. This one again, let's do this with this one. Let's rewrite it this way. So this will be the log. We want to write it as a single log. So this will become a power. So this goes there. So you take this to the third power. So that's 3 squared will be 9. And x to the third to the second, power to a power. Multiply the exponents here. So 2 times 3 will give me 6. So this will be 9x to the 6. And then this will equal with the minus here, and then I'll take the positive 1/3 and leave this as a minus, and I'll rewrite this as the log of x cubed minus 2 to the 1/3. Now here we have a difference right here. When you have a difference, it's going backwards now. It's going to be the log. If this were a plus, then it would be a product. Because it's a minus, it's a fraction here, or a division. So this will be the log. And remember here, you have log, no base. That's understood to be base 10. So this is just be 9x to the 6 over x cubed minus 2 to the 1/3 power. Or you could also write that as the cube root of x cubed minus 2. I'll clear this. And this one says use the change of base formula to evaluate. Use the change of base formula to evaluate. So ordinarily, if this were base 10 or base natural log, base E, you could just use your regular calculator, but here we have to use the change of base formula. So this would equal to, so again, in the change of base formula, you pick the base, and normally the one you're going to pick is either base 10 or base E, because that's what your calculator has. So I'm just going to use base E or natural log, so it'll just be the natural log of whatever this number is 120, divided by whatever the log of this base, whatever that base is. So it's natural log of 120 divided by the natural log of 6. And then you just use your calculator. So in this case, it'll be natural log, it's right here, natural log of 120. Divided by natural log of 6. You can see there it's 2.61, so you can round this off, whatever they tell you here, doesn't say. So you can say it's 2.6, 3 places, 672, or 0.67, if you wrote it 2 places. Anyway, this is your answer here. Okay, let's clear this. And then on the last one, we'll look at the base here is pi. Some cases you could use 3.14 for pi, but the way it works again, I'm going to pick natural log. I could use base 10 again and just put in log of 10 compute, but I'll just say natural log of 5.3 over natural log of whatever that base is. The given base is pi. We come back over here, hit second. Well, I have to go natural log of 5.3 divided by natural log of pi. Hit enter, and you get 1.457. You round out to 3 places. This, of course, is pi here. I'll round it out to 2 places again, 1.46. And that's your solution. Thanks for watching. We'll see you next time.